Good afternoon, everyone. Today we're going to talk about how to check your answer after you integrate something by using the UDU substitution. Alright, so before we start, off to the side I wrote the different derivatives of some trigonomic functions. So the derivative of sine t would be cosine t. Derivative of cosine would be negative sine, and then negative cosine, and then it goes back to sine. So it goes back to positive, and it'll keep repeating. There's reasons behind it. We're not going to get into it today, but anyways, off to what we are doing. So we have our first equation. We're going to integrate the sine of x squared times 2x dx. So we know we're going to use UDU substitution because it's one long multiplication problem. So we're going to write u and then du. So we have to figure out what to use for u. Now the way we do that is to look at the different parts and see if we take the derivative of a part of it, if it'll give us another part. So we'll start with sine. We know the derivative of sine is cosine. We do not see cosine anywhere in here, so we know we are not using sine for our u. So the next part is x squared. The derivative of that is 2x, which just happens to be the next part. So now we know what our u is. So our u is x squared. The derivative of u, du, derivative of u is derivative of x squared, which is 2x dx. Okay? And then now we can do our substitution. So the first thing we have is u, alright, and that was inside of sine. And then we have du. So this is what we're integrating. Now you might be asking, what happened to this stuff right here? What happened to 2x dx? Well, what we said is, it's right here. We said 2x dx is du. So when we wrote du, we were literally replacing 2x dx with du because we said that's what it is. So, with that said, we just have to integrate this. So we have sine. We're right here. Sine t. We don't have sine t, we have sine u. The integral of sine u is negative cosine u. So the integral is negative cosine of u. And when you integrate, the du, it goes away. So it's gone. And then we say plus c, some number. Okay? So now we just have to go back and look. We have this u. We said u is x squared. So u is x squared. So ultimately what we have is negative cosine of not u, but x squared plus c. Okay? So we found the integral. But the question is, do we know if we're correct? Well, what we need to do is do the opposite. We're going to take the derivative of it. Okay? So we have negative cosine. The derivative of negative cosine, here I'm going to use a different color, right here. So the derivative of negative cosine is sine, and that had x squared, times the derivative of x squared is 2x. Alright, and then remember, this plus c, that c was just a number. The derivative of any number is 0. So we don't have to write that. So now we can say dx. We took the derivative with respect to x. So now we just have to check. We have sine x squared times 2x dx, which if you look was exactly what we started with. So we know, since we took the derivative and it came out to the beginning, that we got the right answer. Okay? So let's try another one. So here we have the integral of 12 times, parentheses, 3x plus 1 raised to the power of 3 dx. Okay? So once again, we're using UDU substitution because it's one long multiplication problem. So we have u and we have the derivative of u. So we'll start off with the beginning. 12. The derivative of 12 is 0. So we can't do that because if you turn it into 0 and multiply it stuff, you got nothing. So we'll look at the next part. 3x plus 1. The derivative of that is 3. Okay? But wait a minute, what can we match that with, right? Well, there's no other variables, and there's no sine or cosine or anything like that. So we're going to have to look and say, hey, if we get a number, this is a number. So it's only numbers. So we know we're going to use that. So here we go. U is 3x plus 1. And the derivative of u is 3 dx. All right, remember this dx just means you took the derivative with respect to x. Now, from here we need to use old school algebra. What we don't want a number and then dx. Okay? Let me reiterate this, or let me clarify that. Here, it was fine. 2x dx, that was fine because there was a variable with dx, or if it would have been cosine dx, it would have been fine. But here we just have a number. So we want to get dx by itself. So to do this, we have to do like algebra. So we're going to divide by 3. So if we do one thing to one side, we have to do it to the other. So we're going to divide by 3. So what this does is now we have du divided by 3 is dx. Okay? Now we can go ahead and replace stuff. Because here we go. So we have our u. Okay? So 3x plus 1 was our u. 3x plus 1, 3x plus 1. And it was raised to the power of 3. And this was being multiplied with 12. So that was being multiplied with 12. And then we have our dx, which is now du divided by 3. So du divided by 3. And this is what we're going to integrate. Now, before we integrate it, we have to remember, since it's one long multiplication problem and something is being divided by 3, that means everything is being divided by 3. So in reality, what we have is 12 divided by 3 is 4 4 times u to the power of 3 du. Sorry, having technical problems. And this is what we're integrating. Okay? So, I forgot to write the integral symbol there. So, here we go. U to the power of 3 becomes, the integral of that is u to the power of 4 over 4. And then we had that times 4. So that's the integral. Remember, when you integrate, the du goes away. So this is what we got. So this is 4 divided by 4. That goes away. And we have u to the power of 4. Okay? Now we just replace u with what we said it was. And what was u? U was 3x plus 1. And this was all to the power of 4. And we're done. We found our integral. But now we have to double check. How do we know that we have it correct? Well, we just got to take the derivative. Okay, so let's go ahead and do that. So, different color, taking the derivative of this. So remember, you raise or drop the power down, so we have 4 times the stuff that was inside of it, 3x plus 1, now it's to the power of 3, times the derivative of the stuff that was inside. Derivative of 3x plus 1 is 3. Alright, and that was, we took the derivative with respect to x. Now we just have to do the little multiplication. We're going to simplify it. 4 times 3 is 12, parentheses, 3x plus 1 to the power of 3 dx. Now we just have to check. Did we get what we started out with? Sure enough, this is the same as what we started with. Okay? Now, we're going to do one more. Here we go. We have the integral of 2x plus 3 times x squared plus 3x raised to the power of 2. So it's one long multiplication, so therefore u and then the derivative of u. So we'll start with the first one. Derivative of 2x plus 3 is just 2. Don't really see that anywhere here, so we're not going to use that. What about the next one? X squared plus 3x, derivative of that is 2x plus 3, which is that, so we know we got our u. So our u is x squared plus 3x, and the derivative is 2x plus 3, and we took the derivative with respect to x, so dx. And now we can go ahead and do stuff. All right, so we had our u, which was 2x plus 3, and 2x plus 3, which was raised to the power of 2. Now we have 2x plus 3 is here, and the dx is there, but we have this. But remember, everything is being multiplied, so you can rearrange it in any order you want, and it's still the same thing. So therefore, we took all of that right here, 2x plus 3, and then dx, 2x plus 3 dx, and all of this stuff is du, so we have du. So this is what we're integrating. So the integral of this is u to the power of 3 over 3 plus c, and we integrated, so the du goes away, and this is what we have. All right, so now we just have to replace it. So our u was x squared plus 3, so we have x squared plus 3, and that is over 3. See, u is divided by 3, and u is raised to the power of 3. Okay? What was I going to say? Oh yeah, so this is our final answer right here. So now we have to check our answer. So let's go ahead and check it. Okay? So we're going to take the derivative of this. So, drop down the power. So we have, wait a minute. I feel like something's wrong here. I think I forgot something. I did. Take a look. I said u, right, was x squared plus 3x. So I forgot to write my x. Oops. See, you have to be very careful. You can easily miss stuff. So make sure you read what you write down. Here we go. We're going to take the derivative of this. So we're going to drop the power down. So we have 3 times, x squared plus 3x. Drop the power down. And then that is being divided by 3. Okay? So 3 goes into 3 one time. So that cancels out. Oh my gosh. I'm sorry. I'm being screwed up here. It's been a long day. Okay, so let's try this again. So we drop the power down, and we have that, and then we multiply the derivative of the stuff that's inside. So that's 2x plus 3, and this is all being divided by 3. And then now we can simplify. So 3 goes into 3 one time, so we have x squared plus 3x raised to the power of 2 times 2x plus 3 dx. And now we just have to check. Did we come up with the same thing? And if we look, this is exactly the same as the beginning part. So we know that we did it. All right, and there we go. So if you have any questions, feel free to ask. And with that said, have a good one.